Good day, aspiring builders and construction professionals. Welcome to this crucial module in our building construction training. I'm your instructor, and today we're going to embark on a fascinating journey, understanding the development of processes for the construction of buildings. Constructing a building is far more than just laying bricks and pouring concrete. It's a complex, multifaceted endeavor that demands meticulous planning, rigorous execution, and continuous management. From a skyscraper to a residential home, every successful construction project follows a structured series of processes designed to ensure efficiency, quality, and safety. Our objective today is to dissect these processes, understand their interdependencies, and familiarize ourselves with the essential vocabulary that defines our industry. By the end of this session, you'll have a comprehensive understanding of the project lifecycle in building construction. Every building project typically progresses through distinct phases, often referred to as the project lifecycle. Understanding these phases is the first step towards mastering construction process development. 1. Conceptualization and feasibility. This is the initial stage where the client or developer defines the project's scope, objectives, and functional requirements. We conduct feasibility studies to assess the project's viability, including site analysis, environmental impact assessments, and preliminary cost estimations. 2. Planning and design. This is where the vision takes shape. It involves the collaboration of architects, structural engineers, MEP, mechanical, electrical, and plumbing engineers, and other consultants. They develop the architectural drawings, structural designs, MEP schematics, and prepare detailed specifications. This phase also includes obtaining necessary permits and approvals from regulatory bodies. 3. Procurement. In this critical phase, we identify and acquire the necessary materials, equipment, and subcontractors. This involves bidding processes, contract negotiation, and ensuring the supply chain is robust. The goal is to secure the best resources at optimal cost efficiency. 4. Construction, execution. This is the physical realization of the design. It's subdivided into various construction stages such as site preparation, foundation work, structural erection, MEP installation, finishing works, and landscaping. Strict adherence to building codes, safety regulations, and the project schedule is paramount. 5. Post-construction. After physical completion, this phase includes commissioning of systems, final inspections, obtaining occupancy permits, and addressing any punch list items, minor deficiencies identified during walkthroughs. Finally, the handover to the client occurs, along with as-built drawings and operation and maintenance manuals. Within these phases, a multitude of key processes operate concurrently and sequentially. Let's delve into some of the most critical ones that drive a project forward. 1. Project management process. This overarching process involves defining project goals, setting deadlines, managing budgets, allocating resources, and overseeing all other processes. It includes developing the project charter, creating the work breakdown structure, WBS, and continuous progress monitoring against the baseline schedule. 2. Risk management process. Identifying, assessing, and mitigating potential risks, such as budget overruns, material shortages, or safety hazards, is crucial. This involves developing contingency plans and proactive risk mitigation strategies. 3. Quality management process. Ensuring that the construction meets specified quality standards and client expectations. This includes quality assurance, QA, planning for quality and quality control, QC, the actual inspection and testing of materials and workmanship. Think material testing, structural integrity checks, and finishing quality audits. 4. Safety management process. Paramount in our industry. This involves establishing and enforcing safety protocols, conducting regular site inspections, providing safety training, and ensuring compliance with all occupational health and safety (OHS) regulations. We prioritize zero accidents and a safe working environment. 5. Cost control process. Continuously tracking expenditures against the budget, analyzing variances, and implementing measures to prevent cost overruns. This involves managing change orders and forecasting project completion costs. 6. Scheduling process. Developing a detailed project schedule that outlines all tasks, their durations, and dependencies. Tools like the critical path method, CPM, help identify the longest sequence of activities that determines the overall project duration. This is essential for timeline management. Let's solidify our understanding by reviewing some essential vocabulary in the context of construction processes. These terms are vital for clear communication on any project. Stakeholder: any individual or group with an interest or involvement in the project, such as the client, contractors, designers, and regulatory bodies. Permit: official authorization from a government or regulatory agency allowing a construction activity to proceed. Bid tender: a formal offer to perform a construction job for a specific price. The bidding process is competitive. Contractor: an individual or company hired to carry out the construction work. Subcontractor: a specialized contractor hired by the main contractor to perform specific parts of the project, for example, electrical, plumbing. Blueprint: detailed technical drawings or plans of a building or structure, also referred to as construction drawings. Specification, spec: a detailed written description of the materials, standards, and workmanship required for a project. Work breakdown structure, WBS: a hierarchical decomposition of the total scope of work to be carried out by the project team. Critical path method, CPM: a project management technique used to identify the sequence of project activities that determines the project's earliest possible completion time. Change order: a formal document that modifies the original contract, often due to changes in scope, design, or schedule. Punch list, snag list: a list of minor defects or incomplete items that need to be addressed before project handover. As-built drawings: revised drawings that reflect the actual constructed conditions of a building, including any changes made during construction. Commissioning: the process of verifying and documenting that all building systems, HVAC, electrical, plumbing, are installed and operating according to design specifications. Occupancy permit, certificate of occupancy: a legal document issued by the local government authorizing a building to be occupied. Mitigation: actions taken to reduce the severity, seriousness, or painfulness of something, for example, risk mitigation. Compliance: adherence to rules, regulations, standards, or laws. Logistics: the detailed organization and implementation of a complex operation, especially the movement of materials and personnel. Sustainability: the ability to be maintained at a certain rate or level. In construction, often referring to environmentally friendly practices and materials. For those of you aspiring to roles in construction management, project coordination, or site supervision, understanding these processes is your foundation. Your responsibilities will include process development, tailoring generic construction processes to the specifics of each unique project. Schedule management, creating, monitoring, and updating project timelines. Budget oversight, tracking costs, managing cash flow, and controlling expenditures. Quality assurance and control, implementing and monitoring quality standards throughout all stages. Risk assessment and mitigation, proactively identifying and addressing potential issues. Stakeholder communication, liaising effectively with clients, contractors, subcontractors, and regulatory bodies. Documentation management, maintaining meticulous records of all project activities, decisions, and communications. Remember, effective process development is not static. It requires continuous adaptation, optimization, and the ability to leverage new technologies like Building Information Modeling, BIM, for better collaboration and visualization. To summarize, we've explored how the development of processes for building construction is a systematic approach, guiding a project from initial conceptualization through planning, design, procurement, execution, and post-construction. We've identified critical management processes such as project, risk, quality, safety, cost, and scheduling. And importantly, we've expanded your English vocabulary, equipping you with the precise terminology needed to navigate the complexities of this dynamic industry. Mastering these processes and their associated language will empower you to contribute significantly to successful, efficient, and safe building projects. Keep learning, stay curious, and always prioritize professionalism and excellence in your work. Thank you for your attention. I look forward to seeing the incredible buildings you help create in the future.